For the current distribution, we have the lengthy distribution, but finally we have the result, this one. PDF, second step. Right? Second step to have the result. But it won't be necessary. There you have the result using the chain rule. So think about this. The current result should be the joint distribution, and then we have for the integral. So that says we have for this. CDF, in fact, it should be this. Y and X. Z minus Y and FXY, XY, DX, DY, right? Perform differentiation. Here, I skip the current derivations. And what to do? I have a different color. Well, in fact, this one, we perform differentiation with respect to Z. So FZ, it should be DZ, this one. So where we have Z, variable Z, this one. Z minus Y, right? Well, if we have that one, so perform differentiation. Then we have this. Still the same for Y, but DZ here. Sorry, Z minus Y. Right? So it's all chain rule. How to have a chain rule? Chain rule right now we set variable, for example, the next variable. For example, A. A set it to Z minus Y. And perform differentiation with respect to A, and then perform differentiation with respect to Z. So here, chain rule. Same. However, we have this one, DDA. Right? But you need to multiply chain rule. Is it okay? Set Z minus Y to variable A. Perform this differentiation with respect to A. And then you need to multiply dA over dZ. Right? This is chain rule. If we have a chain rule, then we have the result. But chain rule checking the second part. The second part you will have 1, right? This one is 1, right? Because Y actually is not variable Z, so serving as a constant, so you will have 1. And for this one, actually here it's A, and it's A. Sorry, so nothing infinity. So for this one, actually it's a theorem of calculus. You will have the result by remove it so that you will have fxy, and here which variable you need to set because of x. So x you need to put A here and y. As for the remaining, no need to change. If no need to change, then we have the result. Integral with respect to y. But for the inner side, we have f, y, z. Here we have a should be z minus y, and here we have y again. And finally, multiply 1 and integral with respect to y. So that's why we will have the result like this. Understand this? Okay, then you have 3 seconds, so not second, 3 minutes to check. Everything's okay with the derivation? Go and check, 3 minutes. So we need to have a differentiation with respect to z. And z, where we have a z here. So for y, actually, serving as a constant. So it won't be necessary. So differentiation, we just differentiation with the inner part. And right now, differentiation with inner part, we need to have for the result, we need to perform chain rule. So set the variable here, a, and so perform differentiation with respect to a first, and then dA over dz, the original variable. So here it's 1, no problem, right? For the inner side, in fact, it should be integral from any constant to the variable here. And for the integrand, we have a function with respect to dx. If we have this form, so that says this kind of form. How about this? Any constant, for example, this one, to a here, and here I try to use GA and GX and DX, and I try to perform this with respect to a, then reduce to this G. Here variable is S, so right now it should be A. That's it. So about the result, still remember this. That if you forget that one, it's really easy. Something like right now, this is a so-called here is CDF differentiation, then you will have a PDF, the PDF here. Something like that one. But in fact, it is our result using PDF and CDF. It's the original result in calculus. Right? Calculus, remember this? Calculus, if we have the integral from any constant, maybe right now from negative infinity to A. And for the inner side, function g of s, perform different integral with respect to s. But we want to have the differentiation with respect to a. A actually is a variable here. And then the result should be this. Theorem of calculus. You can look up, find the theorem of calculus, then you can have the result like this. So I apply this so that you have the result. Right now, the inner function should be this, and the variable s, so variable s, and variable s should be replaced by the variable z minus y. So that's why z minus y here. And for the remaining, unchanged. So we still have integral with respect to y. Well, up to now, still the same. CDF first, and then perform differentiation, we can have PDF. Well, for this, still that we have 1 minute to check. It's okay. So let me check with Alice first. Okay. About the derivation. Okay, right. And that. And Dawi. Can you follow? Chain rule. This one actually applies the result. So we just use the function here, but replace variable here with respect to s, variable s by a. What difference of function by dz over chain rule, because we set variable a, perform this differentiation with respect to a. Chain rule asks you need to multiply dA over dz. Right? It's chain rule. Well, that's all. So let me check it again. So That we up now is okay. So that you members know. And maybe Robin? Fine. If so, we will have a formula like this. So that's all. And I try to use this example to serve us the possible example. And as for the others, similar idea. Deriving and try to perform differentiation. Maybe for different cases, you need to have the different way. But this time, this way, we have this one to have the result. Of course, don't forget, this one, we need to find dz. And same for the other cases, you need to find dz. Find the suitable region for dz. Well, so up to now, we can derive the results using this one. Is it okay? This example. So let me go through this quickly. Are we okay, right? And that okay, right? And Robin and Alice. So if it is okay, then I think for the remainder, you can discuss with the person understood. Now, all right.